method or scientific process. It's not, and this often gets sort of shoved down your throat if you talked about this in high school or somewhere else, that you have to follow these steps to do the scientific process. Well, that's not really the case. It's just a general set of steps that we use to logically and systematically study the natural world around us. Right? So we can say that the scientific method is a systematic way to study and understand nature, right? Everything around us, and also, what's going on in us as well, because we are part of nature. And when we get further down into the semester, right, we're going to be looking at the processes that happen inside of us. That would be in the biochemistry part of the course, and we use the same process to study what's happening inside of us as well. And oftentimes when you hear the term scientific method or scientific process, you may think, well, that's only something that you do in the laboratory or in the lab, or you have to be in a special setting to do that. That's not the case, right? You actually use the scientific method all the time without, really thinking about it. Just the way that you would solve a problem at home, for instance, contains lots of the different facets or different characteristics of the scientific method or the scientific process. So your book has a really simple but a really important way in which we can follow the scientific process. And if you'll notice here, the scientific method, it all starts with making good observations. All right, so what would be an example of an observation? Raise your hand if you can think of an example of an observation. Something that you observe. Yes? The table is black, right? So you observe the color, something you see with your eyes. Can an observation only be something that you see? Can it be other types of things? Something you experience? Something you feel, so like hot or cold? So touch. What about something that you hear? Could that be an observation as well? Yeah, all of those can be classified as observations. All right, so something that you see, you feel, you hear, ... right? So observations can be varied in terms of what they are and how we report them. Making good observations is the important starting point here of the scientific method or the scientific process. Based on those observations, then, we can come up with a hypothesis to try to explain or to understand what it is that we are observing. Right? And the term hypothesis may seem also like a fancy word, right? But really what it is, right? It's an educated guess. Or a tentative explanation. For those observations that you make. We'll go through a simple example of this process here in a second. So based on our observations, things that we see, hear, feel, whatever, we can come up with a tentative explanation to explain that. And then we can devise and perform some experiments to test that hypothesis or that educated guess. Right? So your experiment or experiments, depending on how many you have, right, these are devised to test this hypothesis, or you may have multiple hypotheses. All right, based on the results to those experiments, we can come up with a conclusion that either supports or refutes that hypothesis. Right? If it supports a hypothesis, then we can consider it a theory. If the results to those experiments do not support that hypothesis, well, then we repeat this process again. We come up with a new hypothesis, and then we test that new hypothesis. So it's like a feedback loop, a cycle that we constantly go through, not just in science, but in all the branches of science, including chemistry. All right. So two terms that we also talk about or see or hear when it comes to the scientific method are the terms law and theory. All right. And it's very important that you know what those are. So a law, right? A scientific law is different than, a state or federal law. Right? You can't choose to break a scientific law, but you can choose to break the speed limit, for instance. Right? Hopefully you don't get caught. So when we talk about a law, a scientific law in science, what it is just a brief statement that summarizes past observations but it also predicts future ones. Right? Laws are sometimes called principles. And again, these are scientific principles, not the principles that you live by in terms of your beliefs and all that stuff. And oftentimes, these can be mathematical formulas that we use. All right, we'll see some of these down the road. Like, for instance, when we get to the gases, there's all sorts of laws that we use that end up being just math that we do in chemistry. Another very important law that we'll see a lot of, which is really at the center of chemical reactions, is the law of conservation of matter. Has anybody heard that law before? The law of conservation of matter? So it's a very simple, well, the name of it is pretty short, but what it means is that you cannot create or destroy matter. That's all that it says. So it's a short statement that summarizes all of the chemical reactions we've seen before, but we can also use it to predict what's going to happen in the future. So for instance, if I start with a certain amount of one thing and I add it to a certain amount of the other thing, the total amount of things that I get at the end should just be the sum of those two things that I started with. Right? It doesn't get destroyed, doesn't get, new things don't get made or extra things don't get made. We just simply convert them to a brand new form. Right? We'll reference the law of conservation of matter down the road. We're going to see it a lot. Also, the other term that we see in science is the term theory. And a scientific theory is not just a theory. All right, a theory in science is very different than when somebody says, oh, I have a theory why this happens, when you're talking in everyday language with somebody. All right, a theory in science is based on the scientific process, which is based on observations, hypothesizing, and then testing those hypotheses using experiments. And as that cycle goes over and over and over again, we gather a lot of data that we can then develop these theories for. So what a theory is, right, it's a model for the way nature is. And it tries to explain what nature does and why. All right, so an example of a theory, and again, it's not just a theory, is the theory of plate tectonics, right? So if you study geology, or if you heard about, if you've seen on the news why earthquakes happen, right? Well, the theory of that of plate tectonics says that the surface of the Earth, the crust, actually is made up of these little pieces that kind of look like, when you hard boil an egg and you crack the shell of the egg and it breaks up into these little pieces. That's what the surface of the Earth is like. And those pieces kind of move against each other. When they run into each other, that's when you get your earthquakes. Right? All of the evidence that we've seen so far supports that theory. And we can use that to describe not just not just that earthquakes are happening, but we can also use it to predict why, or to explain why earthquakes happen. All right, so theories in science are very, very powerful things. You'll notice here theories at the bottom of this. So, as we make new observations and hypotheses and we test those, the potential exists for gathering data that do not support those hypotheses, and as a result, the potential exists for theories to be proven false if data and experiments dictate that. All right, so this scientific method, scientific process is what we use not just in chemistry, but throughout all the branches of science, biology, physics, etc. Let's take a look at a very simple example of where we use the scientific process without actively considering it as the scientific process. All right, so let's say we make a very simple observation. All right, so let's say that you observe that the sound from the radio. Does anybody use radios anymore? You just stream stuff? Okay, so the radio, for those of you that don't know what a radio is, it's like a little box with an antenna that tunes into the frequency that's going through the air, like right now, right? So some of the cars still have radios in them. You can tune it to like 94.5 or whatever your favorite, oldies station or new whatever. Alternative rock or whatever. If you're a Swiftie or a Belieber or one of those people that follow the current music. So the point here is the sound from the radio, you listen to it, right? That's an observation. It sounds garbled. In other words, it's not coming through the way that it should. It's not clear. It's not crystal clear sound that's coming through. That's an observation, right? You make it with your ears. It doesn't have to be with your eyes. So that's our observation. We can come up with a hypothesis, an educated guess as to why the sound from the radio sounds garbled. And a very simple hypothesis could be that the radio is not tuned properly to that particular station. All right, your hypothesis or hypotheses don't need to be really complicated things. Actually, the opposite should be what you want to. They should be simple things, simple hypothesis that you can test. Can you test that hypothesis? Yeah, we can test it using an experiment. All right, and what is the experiment that we can do to test that hypothesis that the radio is in tune properly to the 94.5? Say that again? Move the antennas, if there is an antenna. How about tuning it to a different station? Yeah, maybe 101.5. Right, so we can tune to a different station. Right, very simple. And then we can make some new observations, or we'll just call this data that we can collect. Right, let's say now we tune into a new station and we find that the sound is still garbled. Right, so does that support or refute my hypothesis? It refutes my hypothesis, right? So it's not the tuning of the radio. Maybe it's something else about the radio that causes the sound to be garbled. So now I can come up with a new hypothesis. So what's another tentative explanation as to why the sound from the radio can be garbled?
Bad area.
You're in a bad location. Yeah, maybe move yourself to a better location. What's another hypothesis? You're too far from the tower, so similar to this, move, get closer to the tower. What about maybe the speakers? Maybe the speakers are bad. Right? That's why it sounds garbled. And if the speakers are bad, can you test that hypothesis as well? Yeah, maybe stick in some headphones and see if the headphones work. So you isolate that speakers and you test it that way. All right. So my point here is the scientific process, right, is not something that scientists only do. You do it all the time. Right? Maybe not every single day, but you do it frequently enough just by doing things logically, right? And that's the point of this, is that it's a logical process that we use in science, not different than what you do on a daily basis. Right? We just put these fancy words to it to make it sound cooler than it necessarily needs to be. All right, let's take a look. See if we can identify these as hypothesis, an experiment, or conclusion. So you go to the gym, and your trainer, if you have a trainer, or you can record it yourself, that you ran for 25 minutes on the treadmill. Is that a hypothesis? I'm sorry, an observation, hypothesis, experiment, or conclusion? So you're recording that you ran for 25 minutes, right? So that would be an example of an observation, right? You're recording, in this case, you're writing down how many minutes you ran for. B, scientific studies show that exercising lowers blood pressure. Right, so that would be an example of a conclusion. Whoops, go down here. Right, so by exercising, we find that blood pressure gets lowered. Right, so we can make a conclusion based on that process, on that exercising. And then C, your doctor thinks that your weight loss is due to increased exercise. That would be a hypothesis, right? So he or she is hypothesizing that you lost weight due to your increased exercise. That's something that you can test either by increasing your exercise even more and seeing what happens, or decreasing your exercise even more. All right, let's take a look at some other ones. The blender does not work when you plug it in. That would be an observation, right? So you can, again, something you observe with your eyes. The blender motor is broken. That would be a hypothesis. The plug has malfunctioned. That would be a hypothesis as well, something you can test. Right? You can test it by changing the plug out and see what happens. the blender does not work when plugged into a different outlet. Right, that's a little tricky one, but that would be an experiment that we can use to test whether the plug has malfunctioned or not. So that would be an experiment. And then E, the blender needs repair. That would be our conclusion or our theory. Right, so again, something that maybe you experienced that on a personal basis recently, right, where your blender malfunctioned. And you had to see whether or not it was due to the plug or something else. So the scientific method, the scientific process is not something that is sort of out there, we do in the lab only. No, we do it all the time, but it follows a logical set of steps by which we can make observations, we can test those observations, we can come up with hypotheses, we can test those hypotheses using experiments, and then we can generate data after which we can draw our conclusions. We're going to see several of these laws and theories when we get deeper into the semester. All right, first of all,